Hello everyone. Today's lesson is on investigating how products form, chemical reactions lesson 3.3 and 3.4. And we're going to start off with some chapter 3 review notes. So if you remember from our last lesson, we learned that burning is a type of chemical reaction and fuels release energy when they burn. And a super important part of this whole chapter is during a chemical reaction, all of the atoms that make up the reactants rearrange to form the products. Okay, so they will always be accounted for, which leads us into our next part of our notes, the law of conservation of matter or mass, that states during a chemical reaction, atoms cannot be created or destroyed. Matter is just reorganized at the atomic level. The possible products of a chemical reaction can be identified based on the atoms that form the reactants. So if you look at this picture, we have vinegar that reacts with baking soda, and it produces carbon dioxide, sodium acetate, and water. Clearly different substances. And if you were to stop and count the atoms on either side of the arrow, you would find that you have the same amount, which proves this law to be true. So consider a situation in which one atom appears to change into a different atom. Jessie is a student chemist who assists Dr. Young in her lab. While she was working, Jessie added some chlorine gas to a container she thought was empty. After Jessie added the chlorine gas, however, a solid yellow substance formed in the container. Jessie tested the substance and identified it as sulfur. When Dr. Young asked Jessie to explain what had happened in the container, she claimed that a chemical reaction had changed the chlorine into sulfur. So let's look at Jessie's claim. A chemical reaction changed the chlorine into sulfur. And we're going to look at this visual here of what she was seeing. She thought the container was empty. She added chlorine into it, and what came out was sulfur. So, do you think that the container was actually empty before Jessie added the chlorine? Let's look at what might have happened during the chemical reaction that caused the sulfur and hydrogen chloride to form. This is a possibility, and as you're doing your activities today, you will have access to this diagram as well. So I want you to think about what happened during the chemical reaction that caused the sulfur and the hydrogen chloride to form. So think about your thoughts here and what it might be. What might have happened, that is. You will use a chart like this to help you with the different types of substances. There are groups of repeating atom patterns, and then the properties of each one, because we want to be able to identify the correct substances. Okay, so we're going to return to chapter 3 questions here for a little bit, because the people of Westfield are still waiting on an answer to their question. What was produced during the chemical reaction between the iron pipes and the fertilizer? To help answer this question, Dr. Young has provided you with the atomic scale model on the next slide. Examine this model and use it to answer the questions. This will come from your work today. We're just going to go through and show you what this was, okay? So what was produced during the reaction between the iron pipes and the fertilizer? Here is what you saw last time. We have iron, we have fertilizer, we have actually 3 molecules of fertilizer, and what we have on this side of the arrow is rust. And rust is made with 3 oxygen atoms and 2 iron atoms. So claim 1, during the chemical reaction only the rust was produced, or claim 2, during the chemical reaction the rust and another substance were produced. You're going to have to answer that in your work today, so be thinking about that. So this is also part of your assignment. When you do this, your goal is to create a model that shows what was produced during the chemical reaction between the iron pipes and the fertilizer. You're going to color in the befores and with the different colors. You're going to describe or draw the product or products that were formed. And then finally, after that, you are going to draw an atomic scale model of everything that was produced during the chemical reaction between the iron pipes and the fertilizer. Okay, and then you will also need to make a key that will match the color coding that you're going to use. Okay, so this will be on page 54 in your packet. You don't need to stop and do it now. That's just where it is. Okay, so if I could get to the next page, here we go. So the atomic scale model of the chemical reaction in the Westphal's water, this is in your work as well. You're looking at what is that unknown substance. That's your goal for today, is to figure out how the iron pipes in the fertilizer had a chemical reaction that created the rust. But since we know that we're missing a lot of atoms over here, we know that there's something else. We need to figure that unknown substance out. Okay, so our key concept today is during a chemical reaction, atoms cannot be created or destroyed. This is the law of conservation of matter. Atoms cannot be created or destroyed. They are just rearranged. So remember this key concept. Oh shoot, I wanted to make that look a little cooler, so let me do it again. Here's our key concept, and now you can see the lovely rainbows. Okay, here we go. So today's work, after watching this video on Edpuzzle and answering the questions in Edpuzzle, you are going to complete pages 50 through 55 in your packet from Amplify Chemical Reactions 3.3 and 3.4. Remember, at the bottom of each page, it will tell you where you will find it in Amplify. Work with a partner if possible, and always, always write in complete sentences. If you're going to type it, you need to remember to notify me with a big A or Amplify in the written work in the packet. You will definitely have to read and listen to what happens to your food. So when you're done with your written work in the book, you will go to Amplify CR 3.3 Part 4 and listen and read along to what happens to your food. And then number 3, complete the Mastery Check 7 on Canvas. Come up to the front Mastery Check table to do that. And then when you're done with that, you will work on your should-dos. So good job today, you guys. I hope this was really helpful.